a little about myself. I'm Prudhvi Neelakantam. I'm a data engineer consultant at Amesto Analytics in Oslo, Norway. And I have a master's in business analytics at BI, Norwegian Business School. And I have a geek in data and AI. And I currently geek in Azure AI Studio, Databricks, Power BI, Fabric. So BI is my current geek. And in free time, you can find me in outdoors or in fitness. Or I also love board games. So if you are ever in Oslo and for an event or for a meetup, feel free to hit me up. And I write some blogs in my website geekindata.com. And if you have any questions about the presentation or real-time object recognition in general or real-time intelligence in Fabric, feel free to mail me or contact me in LinkedIn by scanning the QR code here. I will also show that in the end of the presentation. So yeah, real-time object recognition using Azure AI and Microsoft Fabric. So here for this use case, we are considering airport environment where there will be a lot of people, objects, and uh, that makes a brilliant use case for real-time object recognition. So, for example, there is a camera in a security control in the airport, which acts as a camera feed, and it detects for the objects. So the use case here is, what if if the security board want to flag certain items like firearms or etc. Uh, it should be able to track or detect those objects and give the security council the real time location of that particular object or the person that is carrying in, and also in a spatial geospatial environment. For example, it's a huge place, the airport. So if the object is detected, where in the airport is the object detected, at what point on the XY coordinates. So here we will be using the Azure AI services to detect the object by using some AI models. And we will be using Microsoft Fabric to plot, to visualize the results that we get from the AI model, and also to plot the particular object or the person location in a spatial format. So a quick intro about two tech stacks, the Azure AI services. As you have already known, AI services has been quite popular since last 1 to 2 years. And in Azure AI services, we have a lot of services that we can use, like bot services, which like a chatbot, cognitive search, which is what we will be using, video indexer to run some AI models on frame by frame on a video format, and document intelligence, vision, speech, language, decision, and Azure OpenAI service, which is also one of the popular services in terms of LLMs. And vision and speech, for example, if we want to use the AI models to run on them, run on the vision or speech to generate the outputs, so then we will be using those services. But for this use case, we will be using the Azure AI Studio and Azure machine learning platform here. And the other part is Microsoft Fabric. And is there anyone that hasn't seen this particular screen until now? I know this is a Fabric Global Conference, but is there anyone that hasn't seen this screen or the items or components of Microsoft Fabric? I guess no one. But Most of the users of Microsoft Fabric will be dealing or will be present in Power BI, Data Factory, Synapse Data Engineering for data engineers, and data science for data scientists, data warehouse again for data engineers, and industry solutions where you want to implement particular use cases. And data activator, which was before as a data activator, now we'll be using Reflex, which is part of the real-time intelligence. So a lot of users in Microsoft Fabric has not really used the real-time intelligence because it is a very use case specific as well. So we'll be focusing on the real-time intelligence components of Microsoft Fabric, by which you can quickly ingest the data in real time and query the data, and also create visualizations and use KQL queries to create your databases, or particularly get some results from the KQL databases here. So in real-time intelligence, the architecture is something like this, where we have the fabric items, where we can use the data sources, like different data sources. It could be from Amazon Web Services, it could be a SQL database, it could be Cosmos DB, it could be Azure Event Hubs, or many such data sources. So after we get the data from the data sources, we will be using the event stream, where we will be ingesting and also event processing, the processing of the data using the event stream item. And once we have the data in the event stream, then we will be using the event house to analyze and also to store the data. In event house, you have a KQL database where you can also store the data. And once we store the data, we will be using to visualize the data using Power BI or real-time dashboards. And we can also use Reflex to monitor or to create some alerts on on the data that we have. Whereas the KQL Whereas the KQL query set, we can create the queries which we want to run on the data to run particular visuals, or to produce shareable tables as well. So these slides will be shared with you after the presentation, and if you have and you can go through the items descriptions as well again. So looking at the architecture of this use case, what are the items that we are going to use, and what are the components in the architecture? So we have an object for which we want to detect, and we will be using the camera to capture that object, and we will be using a IoT device or a laptop to take the camera feed and send it to the model endpoint, which is of object detection model, YOLOF, which I will cover in the next slides, what models to use for object detection and why we are using that models. And we will be using the Azure ML workspace for this to have the model and to interact with the model. And once we send the camera feed to the model endpoint, where the model will be analyzing the image frame by frame, and sends back to the IoT device the particular output, which we will be cloud streaming from the IoT device to the Azure Event Hub namespace. And in the namespace, we have the Azure Event Hub, which is what we will be using to stream the data. And once we have streamed the data, the data streaming is ready, but we have to consume that event stream, which is where the Fabric workspace will be coming into the place. We'll be using a stream job in the Fabric workspace to consume that event stream and do some transformations in the stream job and store it in event house a KQL database, and then we will be using a KQL query set to create customized visuals, customized shareable tables or outputs, and we will be visualizing them in the real-time dashboard here. And whereas the Reflex we will be using directly on the stream job after the transformations to monitor and to alert on real time if particular object has been detected. So talking about the model, which is YOLOF, you only look one level feature. So there are multiple models when we look about object detection. For example, so here I'm in Azure AI Studio, and if you go to the model catalog in fine tuning tasks, we have object detection here. And there are 7 models here in AI Studio, in Azure AI Studio, and we will be using the MMD YOLO model. Why we are using this model is because it is a single layer architecture, and it is compatible with providing and handling the real time data in terms of object detection, and it's quite user friendly, and it also has custom pre-built notebooks which we can use to deploy the model and also to consume and ingest and consume from the model. So a simple input and output to the model, for example, if there is uh, a string of images that we send. For example, the data has image 1 and image 2. We send 2 images, one as a carton and can. So this is the image files that we send into the model, and the sample output will be in this format where it gives us the coordinates of the particular object, and then it also gives us a label and the score of that particular object which has been predicted by that model. So in this sample output, you can see 0.98, which means around 98% the model is sure that it is a carton, and the second one is it is 97% sure that it is a can. So this is a basic input and output from the model. And in inference samples, for example, if you want to deploy this model into the Azure ML workspace, we have a deploy option here, in which we can also get this inference samples. In real time, we will be using this Python notebook or Python sample notebook to deploy directly into the ML workspace. So let's take a quick look into the model, the same notebook here, which I have already deployed. It usually takes around 15 minutes to run all the cells. So I just ran before already. So what it does is basically it takes the Azure ML libraries and imports in here, and then it starts authentication. So it takes an authentication into your Entra using your Entra ID, and you have to define your subscription ID, resource group, and the ML workspace name. And once we have defined those, then once the authentication is successful, then the variables will be defined and stored in that. And we are defining the model name as MMD YOLO model. And here, for now, we will be using this sample data set to test. For example, this one JPG is a tin. So we'll be using this 99 JPG, which probably is a bottle. So we'll be using the image to test if it is detecting correctly. And we define the endpoint also for the model once we deploy into the Azure ML workspace. So here we are here we are ingesting the 99 point JPG image file. And once we see the output from the model, then we see it is a bottle with a score of 0.49, which is not too bad. But here it gives us the raw response of multiple objects in here. And the sample request will be of different strings, but we will be considering the top object or the top box that has been predicted, which is like the first item. And once this particular notebook has been run, then we will consume and ingest. So here I have another notebook where I'm consuming the endpoint from the Azure ML workspace by using the URL and the API key, and checking if it can take my laptop camera and give me the labels and the scores of the camera feed of the frame. So here in front of the camera, it's just a person, so it just labels as a person. And once we run the consume and ingest endpoint, it sends the result to the Azure Event Hub by taking the camera feed and sends to the endpoint, and then it sends back into the IoT device and ingest into the Azure Event Hub. So let's take a quick look at the Azure ML workspace here. Once we deploy the model, once we run that particular notebook, the model will be automatically deployed the endpoint here. And once it has the 100% live traffic allocation, then the model is ready to consume and ingest. So here we will be we can use these REST endpoints and the primary keys, which we will again be feeding into the Python code. And if you want to consume sample code, that is also here, right? And once we run this code and we ingest into the Azure Event Hubs, then we can create the Azure Event Hubs by having a namespace, Azure Event Hubs. And in the Event Hub, we have to define the configuration and also the shared access policies in this. And once we have done that, here we can see the incoming requests over the time, and also the outgoing messages, which are being again consumed by the Microsoft Fabric workspace in the stream job. So these are just the videos which you can also get it in the slides. So a quick check, what we have done until now is we have used an object, and we take a camera and we send the frame to model endpoint of the model that is in the Azure ML workspace, and send back the output, a string output into the IoT device, and then we cloud stream into the Event Hub namespace and Event Hub, which is again streaming into the Fabric workspace. So now that we have the Fabric workspace, let's take a quick look in the Fabric workspace. What is exactly happening here? So I have realized that if you cannot see the if you cannot see the real-time hub, you just have to minimize it on your laptop screen. So then you will be able to see the real-time hub here, where we have the different stream types, and we have the Microsoft sources. Like here I'm using the Azure Event Hubs, which is the Microsoft sources. And you can also use a Fabric events. But right now in this use case, we are only taking the data from the Azure Event Hubs, and we are using the stream jobs, which are the data streams here. So I have made up a workspace here where we will be getting the data or consuming the stream from the Azure Event Hub by using a stream job. And once we have the stream job and the transformations and everything ready, then we store the data in the event house, which is the streaming event house, and the KQL database is the database that we will be mostly using in terms of a real time data. And once we have stored the data, then we will be using the KQL query set to query the data that we have. And once we have the queries ready from the data, then we'll be visualizing them using the real-time dashboard, and also monitor or track them using the real-time the Reflex option here. So let's take a deep look into the stream job we have here. So I have set it up in the live mode now, where we see a data preview from the Azure Event Hubs. What exactly is happening is the same output that we receive here in terms of a string format. We get them in the boxes, and when exactly this event is processed, and when exactly the event is recorded in the Azure event hubs and the Fabric workspace. And we set up a stream job in this, and we will not be requiring the partition ID or the processed times for this use case. We will be requiring the values that are in the boxes and the event iniquity UTC time. So we'll be using the manage fields to select only those fields. And we'll be since it is in a array format, we will be using the expand option to expand the array boxes. And since the model will be predicting a lot of different objects, or creating a lot of different labels, we'll be having a filter that, okay, so I want only the labels which are above 30% of the accuracy score, and we will be getting only those items. And once we have the data which we want to look into, this is the um, this is the data that we will be only requiring after all the real-time transformations. And we also have the Reflex, where we can use it to monitor or alert using the stream again. So once we have the data ready in the stream job, then we will be storing them in the streaming event house. So if you have seen in the last few minutes which I've been running, it has one database, which is a KQL database, and a table with RTOD stream name, and it has a few rows, I suppose. So this is a KQL language, which you can get it in the tabular format. And here we see the the values as the first box with the coordinates of the particular label, and then we see the label, what object it is, and what is the score. So here, since I was sitting in front of the camera, it was detecting a person with 82% of accuracy score. So once we have the KQL database ready, then we will be using the query set to create a particular query. So we want to uh, further query the data in the required format. So we just need the label, the score, and the time and the coordinates of the particular box or the particular frame where this particular person or the laptop or different objects has been there. So once we save the query, and the other new option here is Copilot. You can also like ask Copilot to create some queries, or if you have a question, it will return the queries, and you can also like run them in the query set. And once we have the query set, then we will be using the visualize option to visualize this particular frame or the image. So here I have made a real-time dashboard for let's say if a security person is sitting in front of their laptop and they want to see, okay, how many objects, or like a list of objects has been there in terms of person or laptop or those kind of things. And here we can see the aggregations. And here if the person want to detect a particular object, in terms of here I was using a chair in between the camera feed to detect the chair when it is there with accuracy. You can also see over the time if when the chair was detected and what is the score. So here you can see the query I have written in a KQL query where the label is not equal to the person and equal to bottle. I have to change this to bottle. Yeah. And you can also have different objects detected over the time. So here I have a query of person, the object not equal to the person because there will be a lot of passengers or people moving around, but I don't want them, and I just want the other objects and what are the scores that are above 40%. So here I have different objects like bottle, vase, bird, kite, and different things. And you can also get the list of objects in terms of sorted by the time. In the UTC time, you can get them a TV and also what are the coordinates where the TV is located and stuff like that. Yeah, and once this real-time dashboard it refreshes on the real time, and we want to receive a notification when a particular object is detected or a flagged object is detected, and that is where the reflex comes into the place. So here we have different properties in terms of last 30 minutes. So in the last 1 hour, the different objects that were detected were TV, bird, person, and of course, we have to customize the model if we require any particular flagging of the objects and also of the scores to see what is the highest score of different objects. And here I have a trigger. For example, if a bottle has been detected in the last 1 hour, I was placing a bottle nearby me, and I was using it in front of the camera, so it detects the bottle. And so when a bottle is detected, then it counts the number of occurrences. And here in the act, you can use a Teams message or email or a fabric item. For example, if you want to automate some fabric items, you can also do that. And the other options is you can add a power automate flow. If you want to further connect it with external connectors or something like that, then you can add a power automate flow here. And once a bottle is detected, then it gives me a notification. For example, here it was giving me a notification, bottle detected, need attention. And it will also give me the label and the score of the accuracy. And here I have also used an email option where you can also get an email. For example, uh, yeah. So a bottle detected, score, and the label. So using these reflex options, you can like add a alert when a particular object is detected in real time. So a quick look at the things that we have looked in. So the Fabric real-time intelligence, the lineage of in the lineage view, what we have done is we have taken the event stream, a stream job, and we have stored it in a KQL database, and we have used to visualize those output in a real-time dashboard, and also made a KQL query set of KQL query set with the required labels. And we will be also using a reflex option to alert and monitor particular objects when they are detected. So the stream job, as we have seen, it takes the data from the event hub, manage the fields, expands, and everything that we have looked in the stream job, it runs in the real time. Yeah, the KQL database, Fabric Reflex, a real-time dashboard. Yeah, so a quick recap of what we have done is we have used an object in front of the camera. Again, using frame by frame, sending it to the model endpoint of the model that is present in the Azure ML workspace. And we will be ingesting them using the Event Hub namespace and consuming that using the stream job, storing it in the event house and KQL database, and use a KQL query set to query the data and visualize the data in the real-time dashboard, and also has a reflex to alert and monitor in the real time. Yes, that's all. Thank you so much for attending this session. And if you have any questions, feel free to send in the chat.